Hello again, everybody. We are now looking at 4.4. This is the last section of this chapter involving inequalities. We have the same steps we had before. All you notice is that we're expanding to include parentheses and other possible problems. Now, in this case, notice again, we have the compound inequality because you had two less than symbols, and so we are going to get an answer that is squeezed between two other numbers. Same thing's going to happen here. If you notice, we have to multiply out, we have to subtract the 6 and divide by 12, and we're squeezing the answer between two numbers. Same thing's going to happen in this example. I have to squeeze the n, leave it there, take away 6 from everywhere, and you got 24, and then 4n, and then 4, and then divide by 4. And then you're going to get 6 on that n, and finally positive 1, because 4 over 4 is 1. So this is squeezed between two numbers, 1 and 6. Again, we have another squeeze play. Like I call them squeeze plays because they are. Multiply 6k, multiply plus 12, and then we put the other numbers in like this. Take away 12, take away 12, and take away 12. And you're going to get 6, and then 6k, and then you're going to get negative 8. Divide by 6, and since we're dividing by a positive number, the direction stays the same. I have a 1 on this end, I have k there, and I have negative 4 over 3. That's the best I can reduce it down to, and that is your solution. Up here we have an OR situation. Now OR means union. This or that. So I want to make a line right down the middle and do two separate problems. Over here, 3x plus 4 is less than 10. If I solve this one like I normally would, I would get 3x is less than 6. Divide by 3, x is less than 2. Now we come to the OR part. This one, 2x minus 6 is greater than 8, add 6, 2x is greater than 14, divide by 2, you're going to get 7. So we have a situation where the answer could be less than 2 or more than 7. On a number line, this is what it looks like. Here's 0. The first one says from 2, go this way. Remember, you follow the number line. And this one over here, I'm going to put a 7 here, and we're going to go the other way, this way. So the answer could be in the blue area, way over here, or in the red area, but it cannot be between 2 and 7. That's what they're trying to say. So the answer could be here, or it could be over there. Take a look at the next one. The word and means it has to be in both. I'm just going to make a line and do each one separately. And you have that, and you have this. Subtract 5. X is greater than 3. And add 2. You're going to get 3x is less than negative 4. X is less than 4/3. So we look to see where these two areas overlap. Here's my number line. And I'm going to do the first one. Here's 0. Here's 3. it says that this is going to go from here this way. This one says at -4/3, we have this one over here, -4/3, like that. It's going to go this way. This way. Now, the AND says they both must overlap. They have to. But notice that this pair does not overlap. And so this one is basically saying no solution because there is no overlap. They must cross over each other. So when nothing is there, it would be no solution. Now that is different than the or. It could be here, or it could be here. The AND says it has to be in both, and that's why it has to be in the middle between those two. So this one has no solution. Now we're talking about an application problem that you might see on the TSI. It says, Sam has $325 in savings. He wants to maintain a balance of at least means this much or more. $495. Okay, so we're talking about 495 and up. And then it says, but no more than 900. So we have 900 over here. Now, we already have 325. And this is what we don't know. How much do we add to that so that we are maintaining between these two numbers? Well, to find that out, we take away 325 from everybody. Like that, 325. And you're going to get, let's see now, 170 over here. And over here, you're going to get 575. So we can say with a good amount of accuracy that what we need is something between $170 and $575 to make a total sum between these two amounts. Let's take a look at something like this. Now this problem is popular with TSI, so I'm hoping that you can see how this works because the probability of you getting one is high. Tanya had test scores of 75, 86, and 64. 75, 86, and 64. What score must she make on the fourth test, test number 4, to make at least an 82 average? Now remember, at least means 82 or higher. Now I have to add up these scores plus an unknown score, number 4, and divide it by 4. That's how we're going to figure out what we need over here. Well, we can quickly see that we can multiply both sides by 4, and you're going to get 328 over there. And over here, if I add these three numbers, 75, 86, 64, I want to get 15, carry the 1, and I have 16, I get 225. So now I have 225 plus n is greater than this. Take away 225, and you get n has to be greater than or equal to, and that's 361. Now, that's, oh, the 103, sorry, that's 3 and that's 0. And so we can see that 103 is what she needs to make to keep an 82 average, which is pretty high. Okay, and so this is concluding chapter 4.4, inequalities, where you have compound situations and word problems, which are very closely tied to TSI questions.